This is update of the project I have been working on. So it's STM based BLDC motor controller. Here is the source code, and currently it's running this motor on open loop and it's reading the ADC samplers. I can now start the motor from here. And if we look on the oscilloscope, we can see that I can take single shot from there. So if we stop it there, we can already see. So this is the current measurements. And if we zoom closer, we can see that there is a lot of these spikes, and it's because the ADC is running on this low shunt. So it's measuring current on the low shunts. So it always goes to 0 and then it will go back to that value. So the one problem was that how to read that voltage from the ADC without all that noise. And one thing was that like aligning the ADC that way that it will be read only on the center of every duty cycle. So PWM is running on 24 kHz, and on every of those cycles all the currents are measured. Another problem was that this SWDIO I was using for debugging, it's not fast enough and it is losing a lot of samples. If I'm getting 24,000 samples per second on every channel and STMonitor is capable only showing 1000, so it was missing a lot of details. And the new update I did was that instead of that, I started using USB, and I'm sending bigger data packets to USB line. And then I have custom Python script that I can use to see all the like RAW data of that channel. So it's very simple code here. And now I can start this Python script and show again. So now we have this here, and then we can go back here and start running the motor again and go here. So now we already see data coming here. We can stop this and we can go here and we can like take very small area from here. So on this area it's 1 second of like data here, so it's very high speed. But we can we can just choose some area and we can start zooming and we can see very precise data here. If we want to check, we can even see very small noises on this raw data. And the idea was that I will check first how this raw data looks, and then I can do some filtering and then it can be used for the FOC. But this is very high speed data and it's showing 24,000 samples per second for this channel. And that same data will be used for the motor control. And this is historical data, so it's just taking more samples here. But on this same, you can do the same thing, that you can start zooming on some area and you can have very precise data and see all these small noises.